Project is hemoglobin detection from signal to image scanning using photolithomographic technique. Now we are going to discuss the block diagram of our system. This is the block diagram of our system. We are collecting the signal from the extremity such as finger or ear elbow with the help of NIR near infrared, and the reflected signals are captured by using the photonic. These two components are controlled by using the control unit. The control unit, we are giving the power supply by using step down transformer. It will convert 230 volts to the 12 volts. It is mainly useful for controlling the NIR and photonic. Thereby the signal is recorded. The recorded signal will be undergoes image processing segmentation section, where the input signal is converted in the form of image and taken into the regressive analysis. The general lab values are taken and compared to the regressive analysis output. Now we are going to see how the signal will be recorded with the help of CPU software. The hardware is connected to the PC with the help of audio jack. Then the finger is mounted on NIR and photonic. The recorded signal the signal is recorded. The length will be minimum 3 to 5 seconds. The recorded signal will be shown on the desktop. And the signal will be saved. The signal will be taken as the input for the MATLAB.
Now the recorded signal will be taken as the input for the MATLAB. As we are already saved in the desktop, we are opening the file as the input, which will be shown here, and the signal will be fetched as the input to the MATLAB coding. Now the coding will be over. It will be run. During the execution, we are getting the 4 graphs. First one for sigma, the second graph will show for mu, and the third figure will show for peak factor, and the fourth figure show the dynamic range values. All the 4 values are collected, and then these are plotted in the Excel sheet as shown in the desktop. For each patient, we have to take 10 samples of readings, and then we have to store it in the Excel sheet. In order to determine the regressive analysis output, we have to compare the both values of sigma and peak factor for the 10 samples of readings. And then now we have to convert the obtained signal in the form of image. For that, we have to run the signal to image conversion program. After the obtaining of the 4 values, sigma, mu, peak factor and dynamic range, which will be displayed in the command window. If the signal length will be more, then while the execution of signal to image conversion, the image will be break, and then it will be realigned, and then the output will be displayed as shown in the figure 5. In the next stage, we have to go for the regressive analysis. The obtained signal values of peak factor and sigma are taken as x and y of t for the patient, which will be given as the input as shown, and then the obtained output will be which will be the combination of comparison of the values of sigma and peak factor. The coordinating point will gives the output. The output of the patient which we have taken will be 12.1956, which will be displayed in the command window. This is the hemoglobin value of the patients. With this method, we can easily determine the hemoglobin value for the patients. Thank you for listening us.